Hello everyone. In the last video we have discussed about the penicillin and the beta lactamase inhibitors. Now we will discuss the next antibiotic, that is cephalosporin. First of all, we discuss the history of the cephalosporin. Cephalosporin were discovered shortly after penicillin entered into the widespread products but not developed till the 1960s. Cephalosporin are similar to the penicillin but have 6-membered dihydrothiazine ring instead of the 5-member thiazolidine ring. 7-amino cephalosporin acid can be obtained from the bacteria, but it is easier to expand the ring system of the 7-amino penicillinic acid because it is so widely produced. They were isolated from the culture of the Cephalosporin acromonium by the Italian scientist Giuseppe Prots in the 1945. Next point is the 1948. Abraham and its colleagues have isolated principal antibiotic components from the culture of the fungus, that is the Cephalosporin P, Cephalosporin N, Cephalosporin C. These are the three components of the culture of the fungus. Next, in the year of the 1964, the first semi-synthetic cephalosporin, that is cephalothin, was launched in the market by Eli Lilly and Company. Unlike penicillin, cephalosporin had two side chains which can be easily modified. Cephalosporin are also more difficult for the beta lactamase to the hydrolyze. These are the history of the cephalosporin. Next is the classification of the cephalosporins. Cephalosporin are classified into the 5 generations: first generation, second generation, third generation, fourth generation, and fifth generation. First generation, in the first 3 types of the root given. First is the parenteral, oral and parenteral. Parenteral roots given by parenteral roots are those roots which give by the intravenously, intramuscularly, intradermal, that are the parenteral roots which are given by other than the oral root. The examples of the parenteral root given by the first generation: cephalothin, cephaloridine, cefazolin. Oral root given cephalexin, cefadroxil. Oral and parenteral cephadrine. Second generation is the parenteral and oral. Parenteral example the ifamycin, cefotixetine, cefotitan, cefametazole. Oral are the cefaclor, cefaprozil. Third generation, in the parenteral route drugs are cefotaxime, cefagimidine, cefareoxan. Oral routes are the cefixime, cefdrenine, cefibutine. Fourth generation is given by only the parenteral route, that is cefipime and cefipiram. And the fifth generation also given by the parenteral route, that is the ceftobiparol. These are the classification of the cephalosporin. These are the structures of the first generation cephalosporin, in which the thiazolidine beta lactam ring is fused with the 6-membered ring, and the side chain is chain, and the derivatives of the cephalosporin changed. Examples of the first generation cephalosporins are the cephalothin, cephaloridine, cephalexin, cefradine. These are the structure of the first generation cephalosporin. First generation drugs are very active against the gram-positive cocci such as pneumococci, streptococci, and staphylococci. They do not cross the BBB. Full form of the BBB is the blood-brain barrier. They do not cross the blood-brain barrier. Next is the second generation cephalosporin. Examples of the second generation cephalosporin: cefaclor and cefamycin and the cefuroxime. These are the structures of the second generation cephalosporin. They have the greater gram-negative spectrums while retaining some activity against the gram-positive bacteria. They are also more resistant to beta lactamase. No blood-brain barrier penetration. These are the example of the third generation cephalosporins. The structures are shown in these pictures. Examples of the third generation cephalosporins: ceftriaxone, cefixime, and the cefotaxime. These are the structures of the third generation cephalosporin. Third generation drugs exhibit the less activity against the gram positive bacteria but most potent activity against the gram negative bacteria. Extended antibacterial spectrum including pseudoaeruginosa. Less activity on the gram positive bacteria than the first and second generation. It is most active on the gram negative bacteria. It is used for the gram negative bacteria. Highly stability with the beta lactamase. Easy penetrate to different tissue and then have a broad distribution. Little kidney toxicity. These are the fourth generation cephalosporins. Examples of the fourth generation cephalosporin: cefepime, cefepime. These are the fourth generation of the cephalosporin. Deuterionic compound. These are the deuterionic compounds. Deuterionic compounds are those compounds, those molecules which have equal number of the positive and negative charge, that is called the deuterionic compounds. It is good affinity for the trans enzymes, low affinity for some beta lactamase, cross blood brain barrier, and effective in the meningitis. Meningitis meaning is that inflammation of the brain, that is called the meningitis. This is the fifth generation cephalosporin. Examples are given there: ceftabiprole. The structure are given in the picture. Active against the methicillin resistant Staphylococcus aureus, penicillin resistant Staphylococcus pneumoniae. These are the structures activity relationship of the cephalosporin. At the upper side we can see that this cis stereochemistry essential, in which no trans stereochemistry essential. Cis stereochemistry essential for the activity of the antibiotic. Exchange S with the O. If exchange S with the O, that is present at the fifth position, sulfur can be exchanged with the O, that is called the oxazepam. If sulfur is exchanged with the carbon, that is the carbazepam. 6-membered dihydrothiazide is necessary for the activity of the antibiotic. And third position, substituent chemical pentabiotic instability, less effective on the active bacterial activity. R2, R1, R2 and R3 can be changed with the other substituents. Carboxylic acid useful during formulation product development. Beta lactam ring is very necessary for the activity of the cephalosporin antibiotic. Next is the carbonyl group is very necessary. Lone pair of the electron located on the nitrogen atom. Nitrogen at the neighbor of the carbonyl group. Not fed to the carbonyl group to form a stabilized resonance structure, thus more electrophilic for the nucleophilic attack. Last structure activity relationship of the 7th position substituent, that is semi-synthetic incorporation, influence of the antibacterial activity, effect binding the beta lactamase. So 7th position substituent should be semi-synthetic, effect bind the beta lactamase. These are the structure activity relationship of the cephalosporin. Cephalosporin against over the penicillin. Increased acid stability compared to penicillin. Most of the drugs have better absorption than the penicillin. Broad antibacterial spectrum. Increased activity against resistant microorganisms. Decreased allergenicity. Increased tolerance than penicillin. Next category is the Carbapenam. Carbapenams are the class of the beta-lactam acting antibiotics with a broad spectrum of the antibacterial activity. Broad spectrum antibacterial activity are those activity which helps to inhibit the growth or kill the growth of the gram-positive as well as gram-negative bacteria. They have structure that they render them highly resistant to most beta lactamase. Carbapenem antibiotics were originally developed from the Carbapenem thiamycin, a naturally derived from the Staphylococcus catala. Example is the imipenem, meropenem and ertapenem. This is the structure of the imipenem. Imipenem has a wide spectrum with the good activity, many gram-negative routes including P. aeruginosa, gram-positive organism and aerobus. Imipenem is inactivated by the dehydropeptidase in the renal tubules, result in the low urinary concentration. Next and the last category of your syllabus of the 6th semester, monobactam. Introduction of the monobactam. Monobactams are the drug with a monocyclic beta-lactam ring. Monocyclic means mono means one, beta-lactam ring given below of the picture. Monobactam given at the bottom of the picture. They are relatively resistant to beta-lactamases and the activity against the gram-negative rods. They have no activity against the gram-positive bacteria, so it is useful only the gram-negative bacteria. Examples of the Azithromycin tigemonum. We will discuss the Azithromycin, that is the monobactam antibiotics. First, azithromycin is given by the IV. IV means intravenous. The half-life is 1 to 2 hours and it is greatly prolonged in the renal failure. Penicillin allergic patient tolerate azithromycin without reaction. This is the structure of the azithromycin. These are the reference of the topic of the cephalosporin. So we have covered our topic, first topic, beta-lactam antibiotics. Thank you.